All right. Hope everyone is doing well. So, in terms of, I wanted to look at analysis, statistical analysis of a survey. This is something I've always thought about. I analyze experimental data in the lab, but how do we apply it to data we collect, people collect on using surveys, right? This is a good question. How do researchers, if they're investigating a question such as looking at social relationships and how friends are formed in universities, how would they look at it? They can't really look at it in terms of a lab experiment in which you would put people in and then see how they make friends. Well, you could do it, but there are some ethical issues. And so the only choice, I believe, would be if I want to look at how relationships between people are formed in a university setting, the lab wouldn't be beneficial. An experiment in a lab wouldn't be beneficial because I would have to control a number of factors. But with a survey questionnaire, I can get self-report from various people. 100 applicants easily could answer this question. And I did do this in my class. I was teaching I'm teaching a course in research methods in psychology, and we were looking basically, I introduced survey as part of the chapter, which is related to the textbook chapter. And I wanted to try out a survey in class and only got 12 responses from the students. In any case, it is interesting that the questions that I provided actually elicited some responses. And so this is what I call the survey, University Friend Survey. And there was not really any purpose. I just wanted to see that how could I look at uh, the types of relationships between people in a survey, using a survey, and how friends are formed using a survey. And what is the purpose of these relationships in a university setting in terms of this survey? But this kind of survey could also be useful to examine, for example, course evaluation, how students think about a course. And in terms of social psychology, I mean, it would be relevant in terms of how friends are formed in a university setting, outside in a workplace, for example, how employees form relationships in a workplace. That could be also beneficial. I mean, you have the first time employee comes in to the workplace, like maybe a business setting, a bank, and starts working in a bank. How does he or she form a relationship with other people? And does this relationship with other people in terms of number of friends affect the employee's performance in the bank, for example, or even a hospital or in a government building or in the courtroom, right? So, and does across, like, you can also think about it as the progression in terms of the person's career. Does it relate to the number of friends they have in terms of performance and so forth? So here's some questions I had. How many close friends have you made um, since starting university? So this was a question I had. So this is a type of multiple choice format type of question. None, one to two, three to five, more than five. So a standard type of survey question. You can also have a different type of survey question where you have a rank. So strongly disagree to strongly agree. And so you can have, how strongly do you agree with the following statement? Having friends at university makes it easier to manage academic stress. So this is an interesting thing. I wanted to look at, uh, does the friends you have make it easier to manage stress? I mean, some students have a lot of friends, and why do they have so many friends? It might be to reduce academic stress. And certainly being in university is very stressful in terms of the number of courses you're taking and the academic stress, right? So this could be an interesting question to look at. Where did you meet most of your university friends? So this is the location. Where do the students usually meet for the first time? Where do they? meet the university friends? I mean, this question could have been more clear in terms of um, when they met their first, where did they meet their first time they met their university friend, right? When they made friends. In class and residence, describe a memorable experience you have had with a university friend that helped strengthen your friendship. So the earlier one was more of a checkbox thing, and I should have indicated if they could have put in multiple choices here. So you could make, I guess in Google Form, you could make a selection here. But Google Form is not as sophisticated as SurveyMonkey, I believe. And here you have a text. You describe a memorable experience you had with a university friend that helped strengthen your relationship. And here you can enter text in here. And so that could be related nicely for thematic analysis. It's a form of analysis and surveys. And demographic, are you first year, second year, third year, fourth year, or above, or graduate student, right? Now, these are simple questions in a survey, and I'll show you a more sophisticated survey, which I generated the data myself without testing people. So I included the participants here from the 12, but also added in some computer-generated data, and the additional questions are added in. And so that I'll show you later. So now let's look at the responses. And Google Form did provide some responses. So how many close friends you have made since starting university? Well, it looks like from the data, uh, mostly people have in between 1 to 2 and more than 5. So it's a equal range. Surprisingly, it's equal, but we have a small sample size of 12 people. Only 8.3% said none, and 25%, so that's 3 out of 12 said 3 to 5, and more than 4 students said 33.3%, and then 4 students said 33.3%, right? So that pie chart is actually useful in describing um, in terms of how many close friends they have made since starting university. I didn't really define close friend versus distant friend. I could have been more clear. And so I think in survey, you need to really word the question properly and to get a clear response from the participant. How strongly do you agree with the following statements? Having friends at university makes it easier to manage academic stress. And surprisingly, 5 out of 12 students said the having friends does make it easier to manage academic stress. Only 25%, so that's having friends that make it easier to manage academic stress. So I believe if I had a larger sample size, about 100 students, most of them, maybe around 70% would say having friends at university makes it easier to manage academic stress, right? But obviously, there's going to be individual differences between students. Some students obviously will usually have two friends, and uh, they don't really feel that the friends are for the purpose of managing academic stress. Really, is it more for social activity or just making believe? Where did you meet most of your university friends? So most people, 10 students said it was in classes or labs. 4 in residence or in dorms, 4 online through clubs or student organizations, 1. Um, so this could be a repeat. Some people might have chosen, some student participants might have chosen 2 choices instead of 1 choice. So this is why there could be a difference. But it's interesting that where they meet most of their university friends is in class or lab. Describe a memorable experience you've had with a university friend that helped strengthen your friendship. Again, this question uh, could have been more clear, I think. Well, it means that you already have a friend, a university friend, but how did that memorable experience strengthen your friendship? So we were playing a game and ended up playing for a long time, helping me proofreading my essay. So here's something where there's a more academic support. Here, studying for midterms together, studying for difficult courses, studying together for exams, studying at night. So it seems that it's more about when the friend is working with the student in a more, um, I guess, academic setting where they're working together on a project or something where they're working on an essay or studying together for an exam or a test. These seems to be more, surprisingly, a more memorable experience, which helps strengthen the university friend. The other types of activities went hiking together, so some extracurricular activity. We say the man life on a Halloween. So these, but most of these seems to be more about working together on an academic project or something. So that actually is interesting. And demographic categorical information. So most of the students were obviously this was a stats course, which is second year. And so you have 41.7%, and third year students also are taking the course, so it's 50%. So 6, 6, 5, 11, and then there was one who was fourth year above. Oh, so that's interesting. And you can see the questions. I can also look at the question part in terms of the four responses. There seem to be, so for each question, I can see how many responses there were. Well, so that's pretty good. All right, so that's the uh, basic university friend survey. But really, I wanted to move on to a more detailed survey and show you how that could be analyzed. What statistical analysis do researchers in more social psychology, for example, would use to analyze the data, but not in the lab, but what about, and or in marketing, for example, how would they analyze the data? So first, let's look at the questions that I have generated, uh, computer, I guess AI generated in terms of the survey questions. These are over here. So we can look at, and you'll notice that there's some certain themes associated with these questions, right? Uh, so for example, they could be for some set of questions is more related to demographics, right? So 1, 2, 3, 4, these are demographic questions. We can say demographics questions. And the friendship network, how often do you meet your university friends? Where do you meet? How many hours per week do you spend uh, socializing with university friends? This would be more the friendship network kind of questions, right? Uh, More about the characteristics of the university, the friendship itself, and the network itself, in terms of number of friends, the rate of meeting the friend, where do they meet, and how many hours per week. And you can also look at friendship and well-being. What is the purpose of having the friends? I rely for emotional support, or is it for academic stress, motivate me academically? I experience loneliness at university. I'm generally satisfied with friendships at university. Having close friends makes me feel I belong at university. So this is more about relating friendship with well-being. So these are questions relating to that. And the last one is more about behavioral and academic reflection, academic measures. So what is your average GPA? Uh, 17. How many hours do you study per week on a scale of 1 to 10? How stressed do you currently feel? And 19, do you live on or off campus? So that would be the behavioral and academic measures. And open-ended reflection is more about answering textual information. So this could be nice for thematic analysis using NVivo, for example. What is your average? Do you live on our campus? So these are behavioral. So behavioral, like how stressed you are, and how do you stress do you feel? Experienced loneliness. That would be one, I believe. Well, the experience loneliness would be more about friendship and well-being. So this would be what is it? How many hours do you sleep on? Do you live on or off campus? So that's more behavioral, right? And academic measures, GPA. But you can relate some of these variables. So for each question, there's a variable, right? So here, for example, a variable is average GPA. Here is the level of yes or no. So this would binary variable, yes, 0 or 1. I'm generally satisfied with my friendships at university. I have close friends. This could have been a more liquid scale in terms of the response. I feel that my friends motivate me academically. I often study with my friends. I believe these were coded more in terms of a Likert scale, in terms of agree, strongly disagree. So 0. So you could code it from 1 to 5 in terms I can rely on my university friends for emotional support. So if we go, so actually I can bring in the other one, which will show you how this would be done. I often study with my friends. So this could have been done strongly agree to disagree, disagree in terms of a rating. I believe, I feel that motivate me. That could also have been done strongly agree to disagree. Well, here, oh, actually, it's already indicated. Sorry. Strongly agree would be disagree. So disagree, and you have it from 1 in the terms of the Likert scale. And then you also have to strongly agree, strongly agree. And so this is a more ordinal level, and we'll talk about that later in terms of the ordinal scale. And behavioral 0 to 4 and academic measures, right? So let's now go to the JASP. So here's JASP. I can import in data into JASP. If you're not familiar with JASP, I think I find it more intuitive and more able to use easier than statistics because the nice thing about JASP is you can show the data and show the statistical output at the same time, or you can also show the your inputs, what you inputted into the statistical test, which has been used, and then also the parameters put in the statistical test, and then you can show the output, right? So that's what is interesting to me. And also JASP is, well, is more about it's free to use and it's open source. So one thing to ask is we have all these questions. So each of these questions there were around, I believe, 20 questions, right? So let's have a look. Yeah. So there were 21 questions. Some of these were strongly the Likert scale, the others were demographic, and others were looking at well-being. Other was looking at friendship network. Others were looking at other questions were more textual in the 20 and 21. So there you have a different types of survey questions are presented here in the University Friend Survey. Now, in terms of so each question has a variable associated with it. So remember year of study, gender, so here non-binary male, prefer not to say female, and then you have the age. So this role would correspond to the participant. And we have around, I believe, 60 participants that took part in the survey. Normally, a survey would have more than 100 participants because of the ease of, and most people nowadays, researchers are implementing a more online survey. So now you have the age. I think based on the age, I can basically see that the age range is between 18 to 29 and the mean was probably going to be 22. You have domestic and the mix of international and domestic students, French made. You can see even some students have more than 10 students made on a basis. How many times the meet? Meet frequency varies from monthly and weekly, so that refers to that. And so each variable is related to a question. So question, stress reduction. So stress reduction one, was here. And so that's question number, so this I believe is question number 9. So question, having friends helps me manage academic stress, manage academic stress. So that's uh, stress reduction. And so they were rating it from 1 to 4 for that, right? 1 to 5, strongly disagree to strongly agree. So this person right here said 4, which means that they don't fully strongly agree, but they are close to it. Having friends help them manage stress. Question 10 was related to support. Question 11, motivation. And then question 12 was study together. 13 was belonging. Having close friends makes me feel belong at university. Question 14, I'm generally satisfied with my friendships at university. And then question 15, we can move on over here. You can see it's loneliness. It's coded as question 15. Loneliness, and then GPA, study hours, stress level, residence, and then we have some textual information. Memorable experience, played games on campus, join a student club together, hike together on weekends, friendship challenge, friends in different programs, balancing time between study and friends. Well, that was a common thing I had in my undergraduate university years, balancing time. Different schedules. Oh, that's a good point. Different schedule makes it hard to hang out. So there you have it in terms of the survey data. But we have all this data. How do we go about analyzing it? One thing you'll notice is what does this is referring to nominal data. So year of study is nominal. So that means categorical. So for example, we can have male, female as a nominal variable. We can have color, black, white, yellow, green as nominal variables. So that's a categorical. First year, second year, third year, fourth year, those are categorical variables, right? But fourth year doesn't mean it's better than third year. Third year doesn't mean it's better than second year. So that's we can't say it's an ordinal. There's no rank to it, right? Uh, so male is not better than female, so nominal makes sense in that case. Now, in terms of ordinal, in JASP, it nicely identifies it as being ordinal. So really, is our ordinal data, remember, was strongly agree, strongly disagree. So here's our ordinal data. And so it's rated from 1 to 5. So if you strongly agree, that's better than strongly disagree. And there's a rating from 1, 2, 3, 4, 5, right? So 1 was strongly disagree, 2 would be uh, moderately disagree, and then 3 would be weakly disagree, and then I think 3 would be agree, and 4 would be moderately agree, and then 5 would be strongly agree. Right. That would be why it would be ordinal. And then scale, you're just simply getting a value, a numeric value, which can be continuous or discrete. We'll talk about that later. So here you have 2.97 of GPA given, so decimal value. Here it's a whole number in terms of study hours. Well, someone cannot have a 0 GPA, right? And that's another point. Stress level, so here's ordinal, residence, and then we have these textual information. So textual information, I'm not sure if that would be classified as nominal data, but it's more text. Yeah. All right. So we've got that part. Now, how do we analyze the data from friendship data? So just as a review, so the type of data we have is we have in terms of the data. So let me put this on one page. Mm. So we have types of data here. So we have numerical data or quantitative data, numerical values, and we have categorical qualitative data. So categorical, for example, first year, second year, third year, fourth year. Numerical quantitative can be referring to discrete continuous. So something like length, height, weight, temperature, these would be continuous. If we can measure, then it's continuous. And discrete, you can count it. If you can count it, then it's discrete. And then you have ordinal. In our survey data, it was strongly disagree to 1, 2, 3 to 5, 1, 2, strongly agree. But you code it as 1, 2, 3 to 4, and 5, right? The nominal data is gender, female, color, blue, green. There's no order to it. Now, that's pretty simple to understand in terms of categorical data. Most students have a difficulty with understanding the difference between discrete and continuous data. And if you can count it, then it's discrete. There's no decimals in terms of discrete data, but continuous data, you can measure it, then it's continuous. It can be decimal, it can be whole. And in terms of continuous data, I think you can figure out that there's interval and ratio. And so what does that mean? Interval means ordered with equal intervals. Differences between values are meaningful. So for example, temperature in terms of degrees Celsius, uh, even zero means something. So there's no true zero in terms of a nothing. Whereas ratio, differences and ratios are meaningful. So a zero does mean something. If you have a zero income of $0, that means you're broke. If your height is zero, that means that's not even possible to have, or it's not even possible to have an age. So that means nothing. Zero is equal to nothing. And so that there you have a true zero. That's true zero ratio. Whereas interval true, there is no true zero. Usually continuous in terms of interval, can have some decimals, and then ratio, uh, there does seem to be a discrete ratio and continuous ratio. So we can think of continuous ratio in terms of height, weight, reaction time. So reaction time is in decimals. Weight, it can also be in decimals. Height can also be in decimals, 5.3 inches and so forth, 5.8. And number of students is a whole number, so these are not decimals. Ratio, I think another difference to understand is you can have 10 kilograms is twice as heavy as 5 kilograms, right? So whereas, but 20 degrees Celsius is not as twice as hot as 10 degrees Celsius because zero does not mean no temperature. It doesn't mean nothing. So the ratio doesn't work for continuous data, where it does work in the case of a ratio scale. Uh, and what interval you can't have ratio data, right? All right, so here's a good explanation. And something else, well, you might know what a hypothesis is, a theory. So I explained it earlier in another YouTube video. But when you get a sample from a population in this survey, let's say we got 60 participants and the data was simulated by the computer or AI, the data, and you get that 60 participants from, let's say, 1,000 university students. Well, that's a sample from a population, right? And from that sample, you get a statistic. And that statistic could be any type of statistic. It could be a chi-square, could be a descriptive statistic, or it could be a correlation, or could be a regression, Pearson correlation, and then it could be a t-test, t-value. But each of these statistics will lead into a p-value if you're making an inferential inference from the sample to the population, right? So we can think about our variables, and each of these variables can be put into categories, right? So the first 5 questions were about year of study, gender, age, student type. So that falls into the category of demographics. And then we have friendship network, friends made, meet frequency, met location, social hours. So this is ordinal ratio data. So that falls into using crosstabs. We can look at frequencies. We could relate two variables based on their frequencies. So frequency of friends made out of 60 students, how many said uh, how many friends they made during university, right? Four. I think around maybe we could say 54 said they made 4 friends during university, whereas Two said they made three, and so forth, right? And so that would call into a frequency. And then bar plots you would have for that. Friendship and well-being Likert, here it's for strongly agree, strongly disagree. And that was related to those questions in terms of the friendship and well-being. I believe it was how stressful uh, you feel, and so, well, that was academic and stress. And that was ordinal, and we can apply reliability analysis. Factor analysis is interesting because we can look at latent variables and the relationship between them. I'll talk about that later. And then correlation, we can look at correlation between variables. Academic and stress, that's another category. GPA, study hours, so that's numeric, study hours, stress level, and then residence, which residence to live in, interval or ratio, and ANOVA, analysis of variance, which you can have one categorical variable and then with three levels, and then look at the dependent variable, which is always numeric. But the outcome for ANOVA and regression is always numeric in terms of the dependent or outcome variable. Correlation, you're looking at two numerical values. Uh, Reliability analysis crosstabs, you're looking at frequency percentages. You can between them. Thematic coding, textual information is interesting how we can use word clouds to infer the data, right? Infer what is the common theme or word. So let's go ahead with analyzing the data. First, actually, this is a good diagram over here in terms of the predictor variable. So here, for example, we have predictor variable, categorical, or quantitative. So it's a good think of what statistical analysis should I do, right? So if my predictor variable or variables I'm using are categorical, so example, if it's third year, second year, first one categorical year. So for example, the school year of the student, and the other categorical variable, well, I guess could be level of stress. I'm not sure if that would be a categorical, but moderate or intermediate or advanced level of stress. And then you could have a numerical value. Um, so if both of them are categorical, if the outcome variable is categorical, you would do a chi-square test. So for example, you are looking, I guess, at, let's see, if the person is level of stress. So if strong, moderate, or weak, so that could be an outcome variable that is categorical. But you can also quantify it as numerical in terms of the level of stress. So 4 could be moderate, weak stress, 20 could be moderate, and then 60 would be high stress level, right? So that could be a quantitative way of quantifying stress. So you can do a means test. How many groups are to be compared? So if you're comparing only two groups, uh, for example, third year, I mean, third year versus fourth year in terms of level of stress, stress being a numeric variable, you would use a t-test. And more than two, you can have paired or independent, but that's another thing. And more than two variables in terms of the groups. So you can do ANOVA, analysis of variance, how many outcome variables. So here, how many outcome variables? So here they could be one outcome variable, or they could be more than one outcome variable. So you can do analysis of variance. Outcome variable, categorical or quantitative. We can also have the case where the variable itself is a quantitative variable. So GPA, for example, is a quantitative variable. And level of stress could also be quantitative variable, and you want to look at the predictor variables here. Let's say you have categorical and you want to look at the outcome, and it's a quantitative. So let's say the categorical is year of the student, and also another categorical variable is Location of the student. If they live in a residence or at home, that could be a two categorical predictor variables. And then the outcome would be GPA. So does those two variables, do they predict, for example, the GPA of the individual? Multiple regression would just be um, mostly numerical predictors, I believe, and then you have and whereas logistic would be more a mix. You have to look into more into that. Right. So that's a good look at that. More detail can be later you'll find out in your statistics course. So how do we go about analyzing this data, right? Um, in terms of the statistical analysis, maybe you already have an idea. First, we would need to do, for example, some descriptive statistics to summarize the data. So in JAS, we can do descriptives here, and I can then move my data. So I will move age, and I'll move social hours. So this is numeric data. GPA could be another variable move, and study hours and stress level. Stress level, right. So stress level actually was, I believe, the ordinal level, but it's coded numerically. Um, and as you can see, we have 60 participants, right? None of them were missing. Usually in survey data, some participants did not input data. And mean was 24 in terms of the mean itself. And then we have social hours 15 is the mean in terms of number of hours, GPA 2.99, study hours 22.33 average, and stress level is 5.5. So if you want to do some basic plots, like if you want to do plots, well, I mean, you can have distribution plots over here. So here we see some distribution plots up here. You could do some interval plots. I'm not sure what this means in terms of interval plots. So you get these. You can do some pie charts. Pie charts are interesting. And you can also look at customizable plots. I believe box plot. Box plot actually just show the, I guess, outliers where the outliers are present. I'm not sure if you can show the outlier. Oh, label outliers. Maybe that is helpful. Uh, yeah, so I do see some label outliers on the data. So here would be the average, the mean, but then you can have a large standard deviation in terms of where the outliers lie. So here, for example, there's some outlier missing. But you need to have a good understanding of the box plots to understand what this means better. And GPA, we can see where the average lies most often in terms of the plot. So this is a good way to present the data to a person in terms of the results of the survey, right? Um, Next, let's do something else. So another analysis we could do is, so based on this analysis, what we can predict is, well, the average GPA was 3.02. So average GPA is around 3.02, uh, actually 2.99, and standard deviation is 0.35. So that's what we would report. The average study hours is 22.3 hours per week, and the average self-related stress, um, stress level was 5.5 out of 10. So I guess that falls into moderate level of stress. So they are not really very stressed. You don't want a high stress level of these 60 students from a university. So question is, does this reflect the population itself? Yeah. All right. So we have these, we could also look at frequencies, right? And then look at the relationship between the frequencies. Here we're looking at counts. So if you look at frequency in terms of, example, friends made, gender, year of study, it will help us to explore some relationships such as year of study and friends made. So we can try doing uh, looking at that. So let's do frequency. So we have to go to frequencies here, and we have a number of tests available to us, but we'll just do um, frequency tables, but it doesn't have frequency tables, so I'll do contingency tables. So it should show. So maybe I can do that. Let's do years of study here, and we have gender, gender. Age. Don't have gender, but I have friends made and that location. Location. No, so this is interesting. I can look at the year of study and then residents and how many were uh, off campus or on campus. So first year, 4 are off campus, and on campus, there are 11, right? I can also look at contingency table, so year of study and friends made. Uh, so I could actually move this down and take up residency all, probably. And friends made first year. Chi-square test shows me um, 12.91 over here. The P is 0.67, so there is no significant association between year of study and friends made. So uh, it doesn't matter which year you are, you're most likely to have similar number of friends made, whether you're a first or second or third, a graduate student. Which makes sense. I mean, the numbers are actually almost similar to each other, and there might be a bit of outliers here. So it seems that we would, I mean, usually we assume that as we progress through university, we make more friends. But apparently, you have the same number of friends in first year, second year, third year, fourth year, and graduate. But again, this is only 60 students, right, in terms of year study. So that's interesting. We can all do, so that's that. So that's a chi-square kind of test, comparing the frequencies. Um, we can also do correlational analysis. So correlational analysis measures the strength of and direction relationship between two continuous or ordinal variables. But again, it doesn't imply causation. So for example, children, let's think about this, for example, parents, children who watch video games bully uh, other children at school. They're more likely to bully, so there's a higher frequency that will bully other children. Uh, does that imply that playing violent video games caused the child to bully more than children who don't watch really violent video games? Well, the other factor could be that the parents might have affected the child's ability in terms of bullying. If a child is raised in abusive family or low income or and so forth, that could affect the child in terms of their behavior with other classmates, right? In terms of the bullying. Incidentally, my daughters also get bullied a lot. Um, But sometimes it's good to be aware of bullying and fight the bully itself, though not physically, but tell the teacher, I guess, would be one way. So how do we go to correlation? Correlation requires two numeric variables. Remember what I showed in terms of the diagram, in terms of the predictor, what are the predictor or the variables you're inputting into the statistical analysis, what do they have to be? And for a correlation, it has to be numeric, and then the outcome variable has to be numeric in terms of the correlation or analysis. If you have, for example, categorical, there is a way to make it more numeric to imply, but it's a more tricky way of doing that. So let's go to regression, and then we go to correlation, and then we can select continuous or and ordinal variables. So let's go to the where we had our social hours. Uh, so we can select, it's not a good idea to select many variables in terms of, because you could have multiple correlations and that would increase uh, a type 2 error, I guess, because you don't want to see, is it a type 1 or type 2? Oh, a type 1 error. You don't want to see a false negative, right? You want to see a true positive, false positive, right? You don't want to see a false positive. You want to see a true positive. So social hours, let's see, we have social hours, question 9. So it should be stress reduction, right? Stress reduction. And then we get support as another variable. And then we have belonging as the other, question 13. And then we have satisfaction. And then we can have loneliness as the other. And then we can have stress level. Where is stress level. And then we can have GPA and study hours. These are numeric. So I guess we can have ordinal and numeric together in a correlation. Um, so where do we see our significant Pearson R? So Pearson R, so this is a good way for me to explain. So let's say you're looking at loneliness and satisfaction on one X and Y. So this is our X and this is our Y. And you get this sort of dot. So we have 60 participants here, right? And let's say this is loneliness, and this is satisfaction, I guess. Satisfaction. And does loneliness follow a more, so the higher the person has in loneliness, the more they would have in terms of satisfaction. So this person over here, for example, has high loneliness and they have high satisfaction, right? So you could say this is 20, this is level 10, so 10 and 20. Whereas here it is satisfaction would be around, I guess, so 2 and 5, right? So that would be a value here. And the line, the imaginary line goes through these points in terms of that. And so that would be, if there's a strong correlation, you would have R is equal to 0.80, positive relationship. And so that would mean that the higher the loneliness, the more satisfied the person is as a university student, and they likely have less friends. So this value over here, the numeric points to the magnitude of the correlation, where the plus or minus indicates if it's a positive or negative relationship. You could also have it a negative relationship where there would be higher loneliness in terms of the lower the loneliness, the more the satisfaction, right? And then it'll go like that. So this would be your, which makes more sense, right? That the more lonely you are, the less satisfaction you have in university. Not sure what kind of satisfaction, maybe it's in terms of your well-being. So let's see what we have here. Satisfaction and loneliness. There seems to be a negative relationship. Well, it's a weak negative relationship, so it's negative 0.08. So that's a weak negative relationship. Um, but actually, this wouldn't be a weak, it would be more. I mean, if you have a 0, that means there is no relationship between the two variables. So that means that there's clearly a weak negative relationship, but it's not a very strong weak negative relationship. If it was a strong, it would be 0. And again, this might be due to our sample size and individual differences between participants. But let's see, if we have a one between uh, social hours and friendship satisfaction. Oh, did I move that in? I don't think I moved that in. Uh, so social hours and let's see, and friendship satisfaction. Did I put friendship? Oh, so satisfaction was referring to friendship satisfaction, right? Social hours. Mm, that's p-value 0.81. Um, that's not really significant. It's negative 0.032. Uh, is there anything which is significant? Which, well, the IP value has to be significant too. Oh, GPA and stress reduction seems to be something that has a significant value. So here, um, anything else which is clearly significant? Oh, and social hours and loneliness. Oh, this is interesting. So here and here, and oh, nothing else. So these are two interesting factors. So GPA and stress reduction. So this is a kind of um, you have GPA and then we have stress reduction. So it looks like these dots kind of show a, um, I guess, a weak positive relationship. So you have a 0.257, which is a positive relationship, but it's a weak positive relationship between GPA and stress, which makes sense. If you are more stressed, you have a higher GPA. Yeah, more stressed, higher GPA. But you have to be adequately stressed, so moderately stressed, and then you have higher GPA, which makes sense. Students who have higher GPA usually have more stress, experience more stress, feel they're stressed more because they're working hard, right? They're studying more. Social hours and loneliness. This is a good, I think this is a good way to explain it. So in terms of loneliness, you have social hours. So let's say there's 2, 5, and 10. And then you have loneliness over here, 2, 5, and 10. So that means this is a negative relationship. So the higher the loneliness over here, the lower the higher the loneliness, 10, and the lower the number of social hours. That makes sense. So the more lonely you are, the less social hours you have. That makes sense. This is a good uh, P is equal. That's a strong, I mean, that would be a moderately negative, and it's significant. It's a moderate negative relationship, which makes sense. The more lonely you are, the less social hours you have, more. Now let's look at support. Is anything significant for support? No, nothing for support. So that's it for an explanation for the correlation part. Let me clear all drawings. Let's do some other analysis. Reliability analysis. So reliability analysis. So if you have, for example, you do a psychometrics questionnaire, maybe you've heard of the Beck depression inventory. So some questions will test your level of assess your level of depression, right? Now, do these questions actually measure depression in terms of that construct? So one part, depression, it doesn't really is quantified, involves a variety of components. For one, you feel sad, emotion relates to emotion. There's also loneliness, which relates to depression, and it also relates to social network and so forth, right? Or amount of sleep you have. And so if you have all these questions related to different themes, do they relate to each other? And this is what that reliability analysis will help us. So does this um, relate to these questions relate to that particular theme? So for example, question 9 to 15, do they relate to loneliness and um, in term question 9 to 15? Let's see. Remember what that those questions were. Um, question 9 to 15. Having friends helps to academic stress, and so these questions are more about the person's well-being and in terms of the student's friendship network. So emotional well-being, do these questions relate to that component? Are they all related to each other? So this is what that reliability analysis will look at. This is better if I look at this one. Friendship and well-being, right? So do these items all relate to this concept of friendship and well-being? Well, if they all relate to each other, if the reliability is the same, then it must be measuring that. So let's do a reliability analysis. Mm, So how would we do that? We would go to reliability analysis, context of, where do I go there for? Let me check reliability analysis. Just trying to figure out where that would be in JASP. How do you do your reliability JASP? So I should add it here, reliability. So I add it here. That makes sense. And then I should do what? Oh, so here. So this is interesting. I didn't know you could add in modules in terms of various SEM, structured equation modeling. That's quite interesting. I do that with survey analysis, summary statistics, um, CHAGs. I don't know about that. So let's go with reliability, and we can do unidimensional reliability. Would that be the way to go about it? Um, I guess it would. Reliability, and we can do analysis, confidence, Cronbach's alpha, and confidence, and then we can add in the variables 9 to 15, and 9, 15 should be added in also. Point aspect. So we don't, Cronbach's alpha is negative 0.163. Um, so that's not a really good reliability, I believe, in terms of a point estimate. And let's see, does it change if I take out loneliness? Negative 0.250. So I was expecting 0.84 as a Cronbach's alpha. Reverse scale items. So loneliness was a reverse scale item. So loneliness was a reverse scale item. Still see 0.246. So seems these items are not as related to each other. So that means that the We don't have internal consistency of the friendship and well-being scale. If, so yeah, it would be unidimensional. So it seems I have a poor reliability for my data uh, in terms of those nine, 1, 2, 3, 4, 5, 6, 7. So these questions are actually, and the answers which are all the questions, there seems to be the scores, there seems to be poor internal reliability. So you would say any Cronbach's alpha which is below 0.6 would be poor reliability. All right, so we can do something else. Next, in terms of analysis, we can do a factor analysis. So factor analysis identifies underlying dimensions, factors among correlated variables. For instance, whether survey items measure social support belonging or academic motivation. And so we have our items, right? And do these items refer to well-being? For example, question 9 to 12. And do these items refer to friendship metric, right? So let's do a factor analysis. So we can do factor and we can do exploratory factor analysis. And for here, we'll look at question 5, question 9 to 15, and move it across. Question 9 to 15, and under extraction, choose factor analysis, principal factor analysis. So we have parallel analysis based on PC, eigenvalues. We could also include, I guess, number of factors based on parallel analysis. So here you have, you can deduce the number of factors, right? And there seems to be only one factor for here. Factor 1 applied over here. And normally you would expect that question 9 to 10 would be more of social support, whereas academic motivation would be question 11 to 12. And question 13 to 14 will relate to another factor. So you would expect 3 factors, right? Try something else. Okay. 3 plots. That's a very interesting. 3 plots. Extraction. Variance. And next we got bucket test. Still getting 1 factor. I guess. And rotation and extension. Principal axis factor. Let's try this. This will get a different factor. Seems to still show factor 1 factor. So 1 factor is just consistent across all 3. I think one of the issues with factor analysis is you need to have more than just 1, 2, 3, 4, 5, 6, 7, 8 questions. in relation to three different factors. Okay, so that's that part. Principal factor analysis. Can I control this maybe? Oh, there we go. Eigenvalues. So when I did number of values based on eigenvalues, I did get three factors. Question factor 1, 0.993, belonging factor 2, and then stress reduction. Uh, hmm, but normally you would get the other factors to be also be present here. So it's not clear why it's not here also for study together and satisfaction and volume. Like, all right, so that's factor analysis. But again, I feel that you need more questions to implement a factor analysis. Let's try a regression analysis. So in terms of regression analysis, that's pretty simple. You have numeric data, so we can, and you have a numeric outcome here. I mean, logistic regression, I think you need a categorical outcome. You can, 1 and 0, binary variables, that would be binomial. Logistic would be categorical, I believe. So let's go with linear regression, stress reduction over here. Stress level goes to my dependent variable. And then I can take stress reduction as my IVs. So would that be factors? Yeah. I can move support. Support is here. And belonging social hours. And all these are factors. But only thing that seems to be significant over here is 0.20, which is the support one. But you have to have understanding of how to analyze regression. Over here, the model is not significant. Statistics, model fit. I think you should just regression model terms statistic. And so that's about regression. How much contribution do the variables play on the predicted outcome, right? So here I have my predictors as being numeric, GPA or social hours, not really significant. And the model is not significant in terms of the outcome, in terms of stress level. So figure that you really need to have more. So it's a combination of numeric and factor variables. So it's not, model is not significant. If it was significant, then I could imply that how many units of GPA contributes to the predicted outcome. You could also put factors in here. And function. Oh, this is interesting. So when I add in study together and satisfaction as the factors, uh, seems to be it does affect the p-value, but one has to have an understanding of what these covariates and factors mean and understanding of these statistical analysis. The other thing we can look at is ANOVA, so analysis of variance. So we can look at one group with three levels. So for example, looking at it and or we could do a t-test. So t-test looks at one group and then looks at two levels between the uh, ANOVA is for three or more groups. So we have, let's do analysis ANOVA, and we can do, well, we can do ANOVA and we will just do, so this is a repeated measures design, so we can have it between the subject. So we have uh, year of study could be one, I guess. Year of study as a fixed factor. And then our dependent variable would be GPA. GPA. So here we don't find any, so it's also important to look at marginal means. So year of study. So you see first year, second year, third year, fourth year, graduate, there is no difference in terms of the GPA. So the marginal means are very useful here. So you don't see any difference in terms of marginal means in the year of study. You could also do a two-way. So this P is not significant, but we could also do in terms of look at another variable, student type. So student type. Well, this number of observations is less than 2 in GPA. Student student type is also not significant. So if it's international versus and here I combined a student type and residence, but there was no significant effect either. The survey doesn't seem to providing much significant results. You can also do a t-test. So you could have an independent or a paired sample t-test. And independent would be comparing two different groups. So maybe because we can do independent sample t-test. So we could, for example, look at student type as a grouping variable. And remember, student type was either international or domestic. And the stress level, do international students have more stress level, higher stress level? We can put that in here. And it seems they do have higher stress level. Bar plots may be helpful here. And you can see, well, international students show lower stress level than domestic students. Now, maybe I could switch this to ANOVA in terms of looking at student type and another factor. So let's try doing that again. ANOVA here, and I would put the student type as a fixed factor, and I could put the residence year of study would be another, and GPA. Is it stress level? So here I have a different numeric variable than before I was doing in the ANOVA. Number of lasers is less after grouping them, so this seems to be less number. So I have only two groups here, so obviously I would see a significant effect. Um, does gender have any significant effect? Actually, gender does have. So student type times gender. And we can look at the marginal means here, which is very helpful. Student type, gender, and display and marginal means. Here and here. And what do we see? So this is interesting. We have to do some post hoc t-tests to explain these differences. So post hoc t-tests. Let's do Bonferroni. I think Bonferroni and Tukey are fine. Where we see the significant effect is the interaction between student type and gender. So it looks like for non-binary, international students have higher stress level. Males, lower stress level for international, female, lower stress level, and non-binary, lower stress level in the international. So it's the females who have the higher stress level compared to the females of the domestic. Whereas in contrast, the males in the international have lower stress level compared to the domestic. So that's interesting in terms of looking at postdoc. But you have to look at a postdoc playtest to see where this, so domestic versus international female. So here we have female, domestic, international. Oh, it doesn't show up as significant here, where that significant effect is in terms of student type and gender. Oh, stress, student type, and gender stress level. So here, student type wasn't significant, and gender was significant. Males, here we can see it. Males seem to be nice. So here I would have to do a post-hoc t-test again. And yeah, 2 point, it's greater. Domestic females higher than international in terms of stress level. Non-binary is higher. 6 is higher than 3. So let's see why the significant is showing up here. Oh, here I see it. Domestic female is lower than domestic male. So that's where that significance is. So it's here. This is where that mean difference is. I was hoping that I would see it here. So this mean difference is not significant. All right, I mean this mean difference, male, domestic, female, domestic, international. That's because this error is so large, right? Okay, so that gives you a view of how you would do it with analysis of variance, and it's looking at categorical variables, but you have a numeric variable. Then we looked at factor analysis, t-test, and so forth, correlation. Now, what if we needed to do thematic analysis? So how would we do that? So does that have that option in terms of descriptives? So basically we have, let's see, why is it descriptive statistics? So how would I do thematic analysis here? Descriptive statistics, and then I move in memorable experience, and then I have friendship challenge, and I can do, let's see, plots. Does it have this variable plots, customized plots? Um, no, it doesn't have any thematic analysis in Jasper. Could I do it using one of these functions here? Let me just check the internet if there's a way. What I was hoping is that I could do a word cloud using uh, word cloud in JASP. So word cloud in JASP, is that even possible? So it seems that JASP doesn't allow me to do word clouds, which is a bit disappointing. But there is another software called JMP, which enables someone to enables the survey person to look at word clouds and look at the data that way. In any case, I'll keep looking at this data in terms of the analysis and figuring out what else we could do in terms of statistical analysis. But I hope it gives you an idea about the range of statistical analysis you can do with survey data in terms of descriptive. Content is descriptive seems uh, as common. Contingency tables are common. You do need a reliability analysis, and I think reliability analysis is important because, and factor analysis is important in the early phase of the survey because you want to make sure that the questions are consistently matching with the theme according to them. So, four questions in relation to, for example, student well-being, and four questions in relation to stress level and so forth. So you want to make sure that the questions are related to that theme. And linear regression is also somewhat common with surveys in which you can look at the predictors and then the outcome and how uh, the outcome, which is numeric, how linear regression can be if one predictor contributes more to that outcome, we can look at it that way. So, for example, study time could be a predictor of GPA in university. The more you study, the more higher the GPA. The more friends you have, more uh, higher GPA could be related to um, that. But, um, so I think for a linear regression, you can't really include categorical variables. Categorical variables would not be suitable. Mm, Yes, actually, you can include the categorical variables in linear regression with numeric, but you would have to code in the categorical variables. But the outcome for a linear regression is always going to be, um, or a multiple regression is always going to be a numeric variable. Whereas a logistic would be uh, more of a binary variable, right? And a logistic would be a combination of categorical variables and continuous variables, and the outcome being binary, right? But for a categorical variable in a linear regression, you would need to code it, right? As 0, 1, 0, and have a reference value. Right, so I hope that gives you an idea about statistical analysis and the use of surveys. Sorry, I didn't really go into detail, um, but it gives you an idea about how you could go about in terms of analyzing data. And I think the first thing really is to test a sample of students with this participants with the survey, and then apply it to a whole population. Not a whole population, but a large sample of individuals. And the first thing would obviously have to do with factor analysis and making sure the questions actually measure what you're supposed to measure, right? And so that factor analysis would be helpful in terms of that part. All right. I hope that was helpful.